Good morning guys and welcome to my channel Mind Your Math. Today we are going to discuss about the nth term from the end of an arithmetic progression. We have already learned about the general formula for the nth term in a normal arithmetic progression, which is the nth term from the beginning. Now we are going to talk about the nth term from the end or the last part of the arithmetic progression. Now, any doubts in the video or any clarifications you want regarding the explanation of this concept, you can mention it in the comments or you can mail me in the mail ID given below in the description box. Now let us see what exactly we mean by the nth term from the end of an arithmetic progression. If you are having an arithmetic progression 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, let it be just an example for an arithmetic progression whose first term is 2 and the common difference is also 2. You know that the fifth term from the beginning of the arithmetic progression is 1, 2, 3, 4, 5. It is the number 10. That is also fifth term from the end of the arithmetic progression. If we are talking about 12, this is the sixth term from the beginning of the arithmetic progression and the fourth term from the end of the arithmetic progression. So, this progression, if it goes on and suppose there is a term which is represented by an, you can say that an is equal to a plus n minus 1d. This is a general form of the nth term from the beginning of an arithmetic progression. Now let us see whether we can form a general formula for the nth term from the end of an arithmetic progression. Let us have a look at this particular arithmetic progression. It starts from 2 having a common difference of 2 and goes up to 40, which means that it has got 20 terms. Okay. Now, let us see the position of a term with respect to the beginning of the arithmetic progression and from the end of the arithmetic progression. You can see that the second term from the beginning is at a 19th position from the end. Similarly, fifth term from the beginning is at the 16th position from the end. 11th term from the beginning is at the 10th position from the end, and 17th term from the beginning is at the 4th position from the end. So I have tried to get into a general formula kind of thing by using the number of terms and the position of the term from the end, because when we are looking at an arithmetic series, our normal tendency is to look from the beginning. So when the position of the term from the end is given to you, we are more interested in finding out where it stands from the beginning. So you can apply the formula for any formula that is applicable to the AP. So 19th term from the end is at a position of 20 minus 19 plus 1th term from the beginning. 16th term from the end is at this particular position from the beginning, and the pattern continues. So if there is a term in the mth position from the end, it is at a position of 20 minus m plus 1th position from the beginning, going by the same pattern. Suppose there are n number of terms in an arithmetic progression and we are bothered about a term which is at the mth position from the end. Its position from the beginning will be total number of terms minus m plus 1th position from the beginning. Okay. Now, if you do not want to learn this particular formula, you are tired of learning formulas, in order to do this particular kind of sum, there is a very easy way. We will be discussing about that also. But before that, let us apply this formula to a particular sum and see whether it is right or not. We have this particular arithmetic progression whose first term is a minus 13 and the common difference is a plus 5, and it goes up to 100 terms, which means 100 is the last term. We need to find the 33rd term from the end. So going by the previous formula, we know that the 33rd term from the end is actually n minus m plus 1th term from the beginning. The value of n is 100, the value of m is 31. Okay, now let us see the position of this particular term and what is the value of the term. 33rd term from the end ends up as the 88th term from the beginning. So now we have to find normally the 88th term of an arithmetic progression. We apply the formula A88 is A plus 87D. Applying, we get the value as 422. Now this is by applying the formula. As I told you, there is another way. It is that when we are having an arithmetic progression, suppose you have an arithmetic progression 2, 4, 6, 8, 10. Suppose I am writing the arithmetic progression in the ulta form, which is 10, 8, 6, 4, 2. This is again an arithmetic progression. The only difference is that now my A is a 10 and my common difference, instead of a 2 over here, it becomes a minus 2. Correct. Now, in this case, the second term from the end becomes the second term from the beginning when we are reversing the arithmetic progression common logic. Okay. Similarly, if you want to find the 33rd term from the end of this particular arithmetic progression, all you have to do is reverse the arithmetic progression, accordingly change the value of A and D and find the 33rd term as usual from the beginning. Now let us apply that particular approach and see if we are getting the same answer. Now our second method. It is going up to 100 terms. So I am finding the last term, which is the 100th term, which is given by A plus 99D. I am getting 482. Now I am reversing the AP. From 482, it is going up to minus 13. Okay. Now my first term is a 482 and my common difference between becomes a minus 5 instead of the plus 5 in the original AP. So now I have an AP with common difference minus 5 and the first term 482. I just need to find the 33rd term as normal. So A plus 32D, you will get the value as 422D. Now it is left to you whether you want to memorize a formula, apply it to the sum and get the answer, or you want to reverse the AP. This is basic understanding what exactly is AP, and even if we are reversing it, we will again end up with an AP but with a different common difference and a different first term. So depending upon your preference, you can choose either the formula method or this particular method. Okay. Find the sixth term from the end of an AP given by 7, 10, 13 up to 184. I have done it in both the ways, but this time I am finding my method to be the easier one. Let us see why. Here A is 7 and D is 3 and sixth term from the end is n minus 6 plus 1th term from the beginning. But I do not know the total number of terms. See, in the previous case, in my own question, I had told you there were 20 terms or how much ever terms were there. But in this particular case, I do not know the value of n. So first I need to find how many terms are there. So I am assuming there are n terms and the nth term is 184. I am applying the formula for the nth term in order to solve for the number of terms which I am getting as a 60. After getting it as a 60, I am applying it in this particular formula. N minus 6 plus 1 will give me 55th term from the beginning, and now I am finding A55 is A plus 54D, which will give me 169. Fine. Now, in the second method, I am reversing the AP. So when I am reversing the AP, the first term becomes 184. My common difference now becomes a minus 3. Now I just need to find the sixth term from the beginning. So A6 is A plus 5D. I am getting 169. Now left to you which method you want to follow, as I have already told you. The first and the last terms of an arithmetic progression are A and L. Show that the sum of the nth term from the beginning and nth term from the end is A plus L. Okay. Now the first term is given as an A and the last term. So let us say it is the nth term, or no, let us say it is the last term. So last term is an L. Now you have an arithmetic progression. What is the formula for the nth term from the beginning? So A plus n minus 1D, where n is our common difference. If we are reversing the AP, the last term becomes the first term. So in the reversed AP, first term is L. Now my common difference actually becomes a common difference with a negative sign because we are reversing the AP. Now what is the nth term from the end, which it becomes the nth term from the beginning for the reversed AP, which is A plus n minus 1 into D formula becomes L plus n minus 1 into minus D. Fine. Now we need to add this as well as this. So let us see what we are getting. A plus n minus 1D is A plus nd minus D plus add this L minus nd plus D. Now when you are adding, you can see that plus nd minus nd and minus D and plus D cancels out, leaving us with A plus L as is required. So what did I do here? First, I took an AP, whose first term is a and the common difference is d, and I wrote the formula for the nth term, which is a plus n minus 1d. Now I reverse the AP because I need to find the formula for the nth term from the end. When I reverse the AP, the first term became the last term of the original AP. My common difference became negative, and I applied the formula for the nth term from the beginning by substituting a as n and d as a minus d. And I just added both of them. The seventh term of an AP is 4 times the first term a. The fourth term from the n is 9 times the first term. If the AP has a non-zero common difference, find the number of terms in the arithmetic progression or the AP and write down the AP in terms of a. Now the second part is, if the sum of the first and the second terms is 24, find the common difference. So the sum is divided into two parts, a slightly lengthy sum. Now let us see how we can apply all the concepts that we have studied so far into this particular sum. Okay. So we know the formula for the nth term is a plus n minus 1 into d. The first term is given as an a, so a is given as an a itself. So the seventh term of an AP, which is a7, is equal to a plus 6d, is 4 times the first term. Okay, now that is our first equation. Fourth term from the end is 9 times the first term. As you can see, fourth term from the end is n minus 4 plus 1th term from the beginning. Okay, which basically tells us it is the n minus third term from the beginning. Now let us write the formula for n minus third term, which is a n minus 3 is equal to a plus n minus 3. Now this takes the place of n minus 1 into d. So it is a plus n minus 4 into d. Okay, now this is given to be 9 times the first term. So this actually becomes 9 times a. Now let us rearrange this equation as well as this equation, write it neatly and see whether we can get any particular value from these two equations. I have written it in a structured way. So first term a is given, common difference, number of terms, and the nth term I have mentioned. Now a plus 6d is 4a. So I am getting a relation between a and d, which is a is equal to 2d. I can also say d is equal to a by 2. Okay. Fourth term from the end, as I explained, is the n minus third term from the beginning. I have written the formula. So this is what I am getting. Now 9a minus a is an 8a, n minus 4n d. I have opened the bracket. Now you get 16d plus 4d is 20d is equal to nd. Now if I am taking d in common, I have told you whenever you have an equation, never cancel out the variables. If it is a common term or common variable, take it outside the bracket. So you will get d into n minus 20 is a 0. It is given that non-zero common difference. It means d is not equal to 0. N minus 20 is a 0, giving n is equal to 20. So there are 20 terms in this particular AP. Now I need to write down the AP in terms of a. So the first term is an a. D is a by 2. So a plus a by 2 is 3a by 2. The third term is 3a by 2 plus a by 2 is a 2a, and it goes on. Fine. Now we have done the first part of the question. Now let us move on to the second part, which says if the sum of the first and the second terms is 24, find the common difference. So you know that the first term is a and the second term is a by 2. No, the second term is 3a by 2. This is equal to 24. So you will get 5a by 2 is 24, giving the value of a as 48 by 5. Now that you get the value as 48 by 5, what is the value of d equal to? D is a by 2, which will give us the value of d as 48 by 10. Okay, the second part was very easy. Actually, once you get the AP, it is just the application of a value to the sum of the first and the second term and then finding the common difference.